Hello everyone. These four letters, WLOG, are perhaps one of the most misunderstood and misused four letters in math. Well, not in math, but in Math Olympiad, because very often we are not sure when we have permission to use it and when we don't. Now, this leads to the phenomena where you are either too careless in using it or too afraid to use it, and both ways are not ideal. So I'm going to have today's lesson slash video slash discussion in the form of a kind of a quiz. We're going to just have a bunch of examples where I will ask you, am I allowed to assume something WLOG? Now, for those of you who don't know what WLOG actually stands for, it stands for without loss of generality. Now, generality just means in general. So it is general enough if what we are doing applies to everything, applies to the complete set of possibilities that are permitted. So for example, if I ask you to explain Pythagoras' theorem, why is it true for all right-angled triangles? You cannot assume that the right-angled triangle is isosceles, because I didn't say that. But you don't have to try to deal with Pythagoras' theorem for non-right triangles, because I just asked you to prove that a squared plus b squared is c squared for right-angled triangles. So the complete set of possibilities doesn't mean everything under the sun, it just means everything that is included within that particular situation. Now, whenever we say WLOG, it is usually followed by WLOG, or we will say without loss of generality, assume some stuff. And the some stuff is often for convenience. If let's say that I say without log, assume that two people playing a game are called Alice and Bob. Now, I just assume their name. There cannot possibly be anything wrong with assuming their names, but if they don't have a name, I have to keep saying the first player, the second player. So of course I can assume that Alice and Bob. But there are many other more tricky situations where it is not so clear whether we are allowed to assume or not. And so I'm going to have a series of examples where your job is to take a look and decide whether we are allowed to assume the thing that I have written down. Beginning with a sequence of a few questions on assuming order. So order meaning sequencing. This is the problem statement. This is the assumption for all subsequent of our mini case studies. Suppose I say that S is a set of n distinct positive integers. Am I allowed to let S be A1 to AN, where A1 to AN are in ascending order? Yes or no? Now for all of these, I'll give a few seconds. You can pause the video if you want to think about it before hearing the answer. Now the answer in this case is yes, this is okay. Because all you are doing is doing naming, which is certainly okay. I can call them A1 to AN, and sorting. This is okay since the question says they are distinct, so I can put them in order. And for this particular example, I didn't give you the rest of the question, so what we will do with this depends on what comes after. So first example, yes, you can let this be your name and you can assume this. Second example, let S be a set of positive real numbers. Can we say without log let the elements of S be sorted in this order from A1 to AN again? Now, what has changed from the previous example? Firstly, it says real numbers, but that shouldn't be a problem. I can still sort real numbers. The difference is that I said a set. The answer is that you cannot assume this unless we know that S is finite. Now, S could be an infinite set, right? If let's say S is the entire set of positive real numbers, how are you supposed to sort it like this? And how do you have actually n of them? So if there are infinitely many, you can't even sort them at all. Right? So this is not permissible. Now, this is something where when you say without log, you have basically assumed that it is finite by naming them A1 to AN. Be very careful about something like this. Sometimes we have made an assumption that is not what appears to be the assumption. Sorting's okay, finite, not given. Next example. Here's an inequality. Can I assume that A, B, C are in descending order? Now, the answer is yes. You can assume that they are in order. Now, the reason is that this is a symmetric inequality. Now, in reality, when we assume that A is greater than or equals to B is greater than or equals to C, this is saying that we are asserting that the other sequences of A, B, and C are all going to be essentially the same. Now, why is it the same? Is that when you have a symmetric inequality, if I permute the variables A, B, and C, it doesn't change. So for example, if I took A, B, C and replaced them by B, A, C, so I swapped A and B, now I end up with this inequality instead. Right, I'm just swapping A and B throughout, which is the same thing. So what I'm saying here is that if, let's say, you had assumed this one, I could have just swapped the rows of A and B, and it doesn't make a difference. And so that's why in this case, assuming A is greater than or equals to B is greater than or equals to C is no problem, because any other case is essentially exactly the same. I don't think anyone is too offended by this, and so let's look at a similar example. Or is it not the same? Now, perhaps surprisingly, the answer is no. You cannot assume A is greater than or equals to B is greater than or equals to C. The reason for that is that if we now swap A and B here in the inequality, these are not exactly the same. Now, of course, you might say, isn't it going to be quite obviously the same thing? And the answer is, well, I mean, I can see where that comes from, and I agree that it would have the same type of proof, but these are not the same thing. And so therefore, you cannot say this, because this is what we call a cyclic expression, but it is not symmetric. Cyclic but not symmetric means that when you loop them around, if you did ABC and you looped it to BCA, it's the same thing. But if you swap things, like let's say ABC to BAC, that will not work. And so you cannot assume that. What you can do is assume the largest one. Because of this cyclic property, you can make ABC into BCA into CAB. So you can, without loss of generality, assume that A is greater than or equals to B and C, but not that B is greater than or equal to C. Okay, let me be clear. You don't really need that for this question. Let's not focus on the substance of the question. Here we are just talking about the validity of the assumption. Okay, so that's enough about assuming order. Let's now talk about assuming values. Here's a geometry question. Not a very difficult geometry question either. What I'm asking is a few different assumptions. Are we allowed to assume area is 1? Can I assume that these lengths are 1? Can I assume these lengths are 1 and 2? Take a moment. If you need to pause it and just draw the diagram, it won't take long. And then see whether you believe this is actually okay or not. 3 separate things. I'm not assuming all at the same time, of course. These are separate assumptions. Now the answer is that the first 2 are okay and the third one is not. But all of these are going to be fairly useless assumptions, but they are valid assumptions nonetheless. Here's why. In this question, there are no lengths or areas that are numerically given. And the problem is going to be invariant under scaling, basically by similar triangles. In other words, the question doesn't really change, right? So if I scale the whole thing up by a factor of 2, the areas would all increase by a factor of 4, the lengths would all increase by a factor of 2, it would not change the correctness of the statement. So I can assume the first one because the area being 1 comes from scaling it down until the area is 1 or scaling up until the area is 1. The lengths AD equals to DB equals to 1, also same thing. But AB and AC are not related to each other, which means that if you assume this effectively assumes that AC to AB is 2:1. So you are assuming something about the shape of ABC. Which is not okay because we want to show this for all possible shapes, well, triangles ABC. So that is not okay. AD and DB, we already know they're equal. So therefore, scaling it to 1 is okay. Now, here's an example from the junior round 2 a few years ago. Couple of assumptions that I'm suggesting. Can we assume that the side length is 1? And can we assume that the square is first cut horizontally and then cut vertically? those of you who already know the solution to this question, you will know that, in fact, the first statement is a key part of the solution. So yes, we can assume the side length is 1 because we can do scaling. Scaling does not change the ratio. Right? If I ask you to calculate the perimeters of the rectangles, then of course scaling will change it. But ratio will not change it. So if it's a big square and I scaled it down to a square of length 1, it does not affect any of the ratios, and so it does not change the question at all. Can we assume that the square is cut horizontally first, then vertically is the other side, which means that, for example, can I assume that what happens is that I cut horizontal lines first like this, and then after that they are cut vertically, sort of like a brick wall, right? Am I allowed to assume this? The answer is no, because this is not necessarily true. It is possible that you end up with something like this, where it doesn't have complete horizontal lines. So you cannot say I cut it into rectangles first, because you can draw the horizontal lines first. Nothing wrong with assuming the order of cutting. But I'm sure that you would say that I don't want to do a question where I say, okay, I cut like that, like that, like that, like that, like this. I mean, how does that help to do the horizontal lines first if it's in this form? So no, you cannot assume that it is cut horizontally into rectangles. You can assume it's cut horizontally first, but that doesn't really help. Now, next up, assuming values. It's a very common round 1 question. Can we say that without laws of generality, we assume x equals to 1? The answer is perhaps a bit pedantic. We can let x equals to 1. But there's no need to even say without log. Now, what is without log? WLOG without log is saying that I am technically adding an assumption to the question, but it appears to be not allowed. However, it is actually okay, right? That's what without log is trying to handle. So like for the previous one, it appears that we cannot just say the square's length is 1, but if you think about it a bit more, it is okay for the length to be 1 because it is not affected by scaling. For this one, when expanded this is equal to this already means that the two things are identical. And identical means that they are the same thing, which means that they are equal for all x. So you're not really assuming x is 1, you're just substituting x equals to 1. Now I'm sure that none of us say without log, let's say when we are told that fx equals to x squared, and then I ask you to find f of 5, you don't tell me without log x equals to 5, right? I mean, no, you just let x equals to 5. There is nothing wrong with letting x equals to 5 because the function is literally fx equals to x squared. So you don't need to say without log, but I think SMO markers and Olympiad markers are fairly kind. If you say without log let x equals to 1, no one's going to deduct your marks for it. But technically, you don't need to say it. You are, however, definitely allowed to let x be anything you want. X equals to 1 is just the nicest thing for this question. You could let x be anything else. It just doesn't help for this question. Finally, a couple of examples on assuming extrema. So extrema is maximum and minimum values. Part 1. of this is from a senior round 2 question from some years ago again. Find all functions f from positive integers to positive integers such that this property holds for all k greater than or equals to 1. Now, question is, are we allowed to let the minimum value of f be n? Are we allowed to let the maximum value of f be n? Not at the same time, of course. These are two different things. The answer is yes to the first one, no to the second one. Because can I let the minimum be n? Well, sure. Because there is definitely going to be a minimum. Has a minimum, but not necessarily a maximum. Because this would be assuming that it's bounded. Just like our earlier example of finite versus infinite, we can't assume that the function is bounded. However, the fact that it has a minimum can be assumed. There's always a smallest positive integer in a list of positive integers. Sorry, so I changed this. This is supposed to be positive real numbers. But the same question. So if we change it to positive reals, how does that affect our ability to assume these two things? Well, no surprise that we still cannot assume the second thing. But we also cannot assume the first thing. The reason why we cannot assume the first thing anymore is simply that there may not be a minimum value of the function. Sets of positive reals may not have a minimum. For example, if I just took the set 1/2, 1/3, 1/4, 1/5, 1/6, and so on, the infinite set, what's the minimum value of that set? Doesn't have one, right? There is no minimum value. It gets arbitrarily close to 0, but there is no minimum value. It doesn't have a minimum. What it has is actually an infimum. Infimum is the greatest lower bound. So the best lower bound is 0, but that's not the minimum value. And for those of you who intend to do mathematics at undergraduate level, you're going to see the infimum and supremum appear quite a lot in your first real analysis course. It is essentially an extension of how we would use the assumption of a minimum maximum when we don't know that a minimum or maximum exists. I hope this helps you to realize that we need to be a bit more careful, but also the fact that we have a bit more permission to assume things than we might realize. So for many of these here, when you are assuming things, be very careful Because if you make a wrong assumption, you may have already have skipped over the entire problem even before we have started, and your WLOG becomes with loss of generality instead of without loss of generality. That's all I have to say on this topic. Feel free to share more examples in the comments below. If there's anything that you've come across where you're not sure whether we're allowed to assume something without log, please share. Thanks for watching, and see you next time.